yung bilang ng imposter eh.
Okay, go lang.
Oh shit!
Hi, Cristel.
Bad.
Hirap naman yun. Uy, nag-double kill sila. 7.
So we're back, guys. 77 is 2.2 times 77, 140. So welcome back, guys, and we are back on our series Programming with Me, and now we are back to see on episode 5, I guess. Yeah, on episode 4 we did Python, and now we're going back to our modules. And as I have said in episode 4, I already prepared everything that I need to prepare. We have the flowcharts, and yeah, we're just going to code. So, our module 3 is about parameters, if I remember. Parameters and values, I guess. Then we learned about pointers in module 3. So yeah, this actually module 3 exercise B, because module 3 exercise A is a written exercise for us. And here we are. This is the problem, and so let's go straight into it. So for instructions, it says implement instructions. Implement the specification below. It's up to you to decide na. We're just going to move on the thing. Problem statement. Create a program that gets 3 largest prime numbers from x to y, and x to y are given by the user. If x is greater than y, swap x and y. If there are no prime numbers in the given range, the program must print 0. And if there is only one prime, print the prime number. If there are 2 prime numbers, print those 2 prime numbers. And yeah, then both prime numbers are printed. I'm assuming that if we have 3 largest prime numbers, we're going to print the 3 large prime numbers. And so let us go straight into the flowchart. So here we have the flowchart. I'm not sure, should I make it white? Nah, we're just going to use orange. So yeah. Oh no, my iPad. Anyways, okay, for our flowchart here we have first of all we ask for integer x and y, and if y is smaller than x, we swap x and y, and from there on we make a prime number checker, which is, oh no, wait, can you save with this? Okay, for our prime number checker, I'm expecting it to be this parts. There. This part of the flowchart. So here we have, I'm planning to do for loops, in which the initial number for it to check is x, and the last number is y. So it checks if I is prime, since we put I as the, what do you call this, as the variable to loop around with, I guess. I mean, we used I as the variable to be processed. Anyway, we check if I is prime. If I is prime, then I will be C, then B will, I will be pointer of C, pointer of B will be pointer of C, then pointer of A will be pointer of C. Actually, pointer of B. This would be from A to B, then B to C, then I to C. So that before we overwrite C, we will be able to copy them with pointer B. If not, we move to the next number, and so yeah. And we check if A and B exist. Initially, they are equal to 0. So if ABC doesn't exist, print 0. If C exists, print C. If BC exists, print B and C. And ABC exists, print ABC. And so let's go to the coding part, in which we are going to use C for this module, since this is our assignment. And so yeah, first of all, we ask for integer x and y. So guys, we're now going to code this thing, in which we are going to use the flowchart for our guide. Actually stressful. Anyways, so now we ask for int x and y, which is scanf. Now the so we have x. Now we have address of x to the address and to the address of y. So there we go. And now if y is smaller than x, oh, I remember, we must have z with it. Now if y is smaller than x, we are going for z equals to y equals to x, and x equals to z. So technically we're just swapping them. And for the next, we are going to make for loops, in which we are going through from x to y. So we have void. I'm going to use void since we don't need to return something, we just need to execute the commands. So we have void, and we are going for void prime check a. So from there we are now on something, and for we must first declare the variable I. Int I for I is equals to x, while I is less than or equal to y, and plus I, so that we increment by 1. And so since we need to check if it's a prime, we are now going to add counter, and we are going to reset the counter each time counter equals to 2. From there, we are now need to create a new thing. There, create a new function, in which I'm going to use int function for it. And nagre-record ako. And prime check b. And from here, what we're going to do is that we're going to make a do while loop. Then while we're just going to make it loop, since it could work. I mean, we are going to start from counter, I guess. So yeah. Now our parameters: counter, and counter, and int I and counter. From there, now we need to check if I is equals to 2. Then we just return 1, since I is an integer, so 2. Actually, we can do or I equals to 3. I just did it too, so that because I is equal with counter. So yeah, is equal to 3, return 1. And if I when divided modulo counter equals to 0, therefore it's a perfect divisor, we return 0. Now if I minus 1 is equal to counter, what we're going to do is return 1, since that means it checked all of the parameters, I mean all of the if statements, and therefore there are no perfect divisor if counter became minus 1 equals to minus 1. And so we have counter plus equals to 1. From there on, we have prime check. Okay, prime check A. Now we're going to call this prime check. For here, prime check I and counter. And we are going to make an if statement. If prime check is counter. Not sure, do I need to put if? Yeah, I think this will do. If I is less than counter. Hi. Send to. Then continue. So prime check. B now counter. So here we have so therefore if it returns 1, it's a prime number, and if it's a prime number, we need to execute this. So we have, of course, we need to go from A to C, A to B, B to C, then C to I, not the other way around, since our problem with it is that we need to store the value of B and C before we overwrite the value of C to I. So yeah, so we have A equals to B. We have B equals to C. By the way, we're not using address because we're just going to copy it. Our goal here is to we are going to receive the address if we are going to write for the address. However, since we are, what do you call this? Since we just need the number, therefore we just need to skip the address and get the number. So that's why I'm doing this equals I. There, yeah, we can just do this because if it's B and yeah, it's not going to skip anything. What do you call this, pointer A equals pointer B. It's just like saying they're of equal value. They're not really pointing to anything. If my explanation is right, that is. So here we have okay. From there we can just A equals 0. So I'm initializing this with 0 so that later on it will be much easier. And we are going to call this, which is prime A. So I guess we need int x, int y, and we are going to make the integers a, b, c pointers. Int a, int b, int c. From there, we are now going to call this, which we have prime check A. Okay, so we have x, y. Since we convert them into pointers, we're just going to use the address. I don't know much about the theory or the explanation behind this, but what is I don't know what I just said. Just technically, it is what it is. Anyways, moving forward. So now we check if A is still equal to 0. If A is equal to 0 and B is equal to 0 and C is equal to 0, we are going to print F just 0. And from here on, we are now just going to copy this. Therefore, C is set equals to 0. And just print F, D, and print C. Else if, and we're going to mess this up, almost messed it up, and else. So now, if A is equals to 0 and none other is equal to 0, technically what this just do is that it checks if everything is equal to 0. Yeah. And if everything is equal to 0, pin 0. From there, pin C, B then C. And I almost have a mistake here because we're supposed to C then B. Now we have D. For the else, we're just going to print all of them. If I am correct, this should be the end of the programming part of this video. And so yeah. Let's hope that this works. As you can see, I have tried it a while ago. Tried doing things. As I told you, oh, ++1, no. We're not supposed to ++1, it's supposed to be ++I. There. Okay. This should work. Supposed to. There, thank you. Actually, this is numer nth recording because I kept messing up, and for the sake of the flow of the recording, I keep doing this program for the nth time already. So yeah, as I told you for the past episode, I'm going to know the code before I show how I program it is, so that I don't really cut much and do have many time lapse, since time lapse can really get boring after a while. Anyways, from there now we are going to test again from 10 to 1. Yeah. Now 100 to 400. 394, 95, 96, 7, 397. Is it prime number? Oh, it's 397, then 389, then 387. Oh, yeah. Then 392, 1, 2, 3. Oh well. And so we have here our prime numbers. Now we are going to analyze what we did. Okay, so first of all, we asked X and Y. For the Z, we used it as what we call this. I guess we'll just go for a sample run, a simulation. So we are going to find, let's say, if X, wait, how do we, oh, if X is equal to, there we go, if X is equal to 5, and I'll put Y is equals to 2, so that we can also run this part of the code. So since Y is lesser than, is less than X, we have Z equals to 2, and we turn Y equals to 5, and we turn X equals to Z, which is X equals to 2. From there on, we have the new values. We managed to swap them. Yeah. From there, we have prime check. I need to comment this out. Prime check 2 to 5. Now the address of A, B, and C, since we are going to make them as pointers. From there on out, we have prime check. Okay, so here we have what do you call this? 5, 2, 5, then pointers. So here we have for I in X. Now for the first run, I is equals to 2. I equals X, which is 2. So I equals to 2, and it's going to run since 2 is less than or equal to 5. This less than 5. So that's why, and since if I is equal to 2, we skip that. It only works for 1 and below. Actually, there are also error prompts, but I did not put it here to save us the time. Now from here we have counter equals to 2, so we run this with I equals to 2 and 2, oh, counting equals to 2. So from there we run it here, do I equals to 2, so here we are, we have 1, return 1, so it's true. And now we are going to check the pointers. So here we have, it's just saying a, the pointer a equals to 0. Since technically it just kept the variable, then it went to the integer. And now b becomes c, which is also 0, and c, pointer c, became it had the value of 2. So there, from there on, we check this and it satisfies, it becomes 3 since increment of 1, and we check here again and it's 3 equals to 1, so from here on it becomes 2, this becomes 3, and still 0 because b is 0 a while ago. Then from there on we have 4, here we have 4 and 2, I mean 4 modulo 2 equals to 0, so return 0, it skips. And for our last number we have 5, and 5 is still equal to y, which is 5, I is equal to 5. So I equals to 5, counter, oh, okay, 5. Then from there on out, let's say it's not 2 or 3, so what do you call this? Yeah, it checks 2 modulo 5 is not equal to 0, and 2 is not equal to 4 either, so it adds 1, then loops it again. 3 is not a perfect divisor for 5, and 3 is not equal to 4, and it loops it again. Now 4 is what do you call this? 4 is not a perfect divisor of 5, so it's equals to 0, it's not equal to 0, and 4 is equal to 4, so it returns 1. And from there on out, this becomes 5, this becomes 3, and this becomes 2, and so it returns here. Now they have values, it returns for C, the address becomes, what do you call this? The address points to 5, the address B points to 2, the address A points to 2. So from there on out, we check if all of them are still equal to 0, which is not equal to 0, that's why we skip this. And is A and B equal to 0? No. Is A equals to 0? No. So therefore, we conclude that all of them must be printed. So that's how I made this code. Yeah, I think it's actually long. Anyways, we are now going to our vlog here, journal or vlog module. So whatever I have learned about void functions, making functions with void instead of int, in which if you have void, you don't really need to return any value. Compared to int, you must return something. For that, sometimes I just return a random thing. What did we learn here? I also learned about pointers, that they get the address and not necessarily the values. That's why what they call this, the indirection skips the var a level. I think I see it as different levels, like let's say pointer, variable, integer, and having a pointer skips one level. So if we have a double pointer and we have, let's say, double pointer, variable, and then integer. If we have one, if we put pointer 1 on our double pointer, we skip the pointer and we go straight to the variable. And we have pointer, we go straight I mean, yeah, we go straight to the integer. So yeah, and I have learned that we can change the addresses. I mean, so a while ago we have the address of A um, pointing at, I mean having the value of 0. So what we did in our program is that I think I'm not a comp sci major, I'm a stat major, I'm not sure of what I'm saying. So in here we have we made the address of A point to a new thing. However, I'm actually pretty curious about this. What if we A, B, C, and we just did this? Will this work? Because if yes, I'm just not going to get pointers anymore. It's crazy. I think this will not work since we just get the value and we're not technically overwriting it. I think. I'm not sure. So we have Ubuntu. So yeah, what have we got more? Yeah, the parameters and as in the function, as I have shown. Whoa. Okay, we have. Okay, so we have CD, MNT, C programs. So from there we have what do you call this? GCC. Yeah. Oh, it does work. So we did overwrite it. 3, 10. This is weird. If what? I'm a bit amazed. Sorry. This is how I learn. I studied things. I experimented things. So here we have pointers. See, okay. So now we are going to GCC. Okay. So we made a mistake there. Okay, GCB. It should be pointer to pointer. Okay, so we're technically giving this pointer the value of this. Yeah. It's on a different level if we did something. 1. Oh, we're going to try 3 10. See? That's 3 10. Are you thinking what I'm thinking? Therefore, it can only work with pointers, overwriting stuff with the use of the address. Let's try it again, shall we? Yeah, we are technically not doing anything with the address. We are doing something with the value of the variable. So yeah, you're just looking at me how I learn stuff. Printf. Now, I guess this will be the last part of my, what do you call this? Vlog. If this doesn't work and if I'm right, then we should not be able to do things. It should be 0 0 0 all throughout. Or it changes, but it won't do anything. No. I guess we can just do this and print it here. Because technically it will change. However, will it overwrite? That's the question. Okay, I'm about to this. Okay, 110. Okay, 002, 023, 023. Okay, then it becomes 000 by the end. And so we have learned that in order for us to, what if I put here? What if we try it in int prime check? And I think that it will just be the same, because the difference is that only void doesn't need to return anything. So yeah, actually this is the original code that I have coded some while ago while I'm answering our module 2B. Module 2 is a written one. So anyways, I guess that will be all for this video, guys. And I hope you enjoy, and for those programmers out there, continue doing the good work. And thank you for watching. Please like and subscribe, hit the like button, and share it with your friends if you need it. Hey, Comsci 21 peeps, you know what to do. Anyways, I guess that will be all, guys. Bye bye, see you in the next video.
Under your toes, the fire grows. You are ready for a different kind of life.